So exam 4 is going to cover these sections, 11.5 through 11.7, all the way up to 13.3. Let's get started with the review. One of the things that it's helpful to know for your review are some of the properties of logs. Now, you've got a couple major properties like this. This is your product rule, law of the product. This is some of the logs, quotient rule, power rule. I like calling the power rule the parachute rule because I always kind of envision this R as kind of like parachuting out front. But there's a couple other ones that are less familiar but very useful. For instance, log base b of 1. Well, what power of b gives me 1? The answer would be 0. B to the 0 power. What power of b gives me b? So if these two match, then this answer should be 1. And let's see if we can't get a better writing instrument here. Finally, log base b of b to the x. Any ideas?
Doesn't that just equal x because the b's cancel?
Yep, the b's kind of cancel. Basically what's going on here is you've got a function and its inverse. So if you do, if you cube a number and then take its cube root, you're going to get back to where you started. If you square a number and then take its square root, you're going to get back to where you started, assuming you started with something positive. So the same things happen here. You got a function and its inverse. Now you can see that in another way, in another form, if you have b to the log base b of x. Again, you've got a function and its inverse kind of back to back. So that'll be an x. All right. So kind of a little background / reminder of what's going on here. And Taylor, I am going to record this, so you should be good in that sense. A little reminder here, again with logs. If I don't write anything, what base is understood to go there with that log? So it'd be log base 10 of x. So that's kind of like the default. Now, typically speaking, you're not going to see anyone write log base e of x other than me. So what notation do you think that the book or WebAssign is going to use for log base e of x? ln. So that's really the natural log base e, or the natural log of x. All right, let's keep going. So kind of taking advantage of that property right away, one of the things you might be asked to do is solve for x in an equation like this. My first step that I would suggest is I would write it, instead of log ln of x, I'd write as log base e of x. That puts something a little more tangible here, and then you can rewrite the equation as the base to this power equals that. And when you do that, that gives you e to the 2.65 equals x. So you solved for x. Now, if you needed to, I say you could probably get a decimal value from this. All you'd have to do is plug that into your calculator. So be careful when you do that, to get to the e to the x key, you got it the second key first. So second, and then ln, and then 2.65. And then round it appropriately. A lot of times I'll ask you to round it to the nearest, say, fourth digit. In this case, the fourth digit is a 0. Do I need to put that 0 there if I'm rounding to 4 digits?
Yes.
Only if you want full credit. So I guess the answer is optional but not optional. Yeah, if I ask you to round to 4 decimal places, there needs to be something here. Doesn't matter if it's a 0 or not. Let's see how well you remember some of our properties from just a moment ago. Log base 6 of 1. What would that equal? 0. Log base 9 of 9. Someone else. Zach. 1. Excellent. How about log base 5 of 5 to the 7th power? Yeah, that looks like a 7. Thank you. Yes, 7. These cancel each other out. Or 8 to the log base 8 of 10. Same kind of thing here, right? Those are going to cancel each other out, so that gives you a 10. That's going to give you what? What am I going to get here for this last one? 4. Nice. Nice. Now the book will write things different there. They'll say, express this as the sum and difference of logarithmic terms. Right? I might just write expand. And what I mean by that is I want you to use the properties of logs like these three, your product rule, your quotient rule, and your power rule. Use these three and these, of course, to simplify these expressions. So the first thing to do is to use the quotient rule and separate it into numerator and denominator. Log of the numerator minus log of the denominator. Okay, that's fine. Now, notice one thing that I did here. I rewrote the square root of x as x to the 1/2. Those two are interchangeable. This part right here is a product, so it becomes the log of the first plus the log of the second. Log base 2 of 2, log base 2 of x to the 1/2. The 1/2, we can use our parachute rule there. That 1/2 comes out in front. But log base 2 of 2, well, I'd probably ask you that you simplify that. What does log base 2 of 2 turn into? A 1. Yep. Nice. Nice. Going in kind of the reverse direction, you could be asked to do something like this problem. Write this as the log of one term. Now, in the reverse direction, I would suggest that you get rid of these coefficients by making them exponents first. And unlike some other books or instructors, I'm going to take the 3 and the negative and put it in the exponent. So this is going to be log base b of x to the negative third plus log base b of y to the negative second plus log base b of z to the 1/2. Now the nice thing about it here is that the sum of logs comes from the log of a product. So basically I'm working from this side to this side. So all these terms that I add up become the log of a product. So it's going to look like this. It's going to be the log of x to the negative third, y to the negative second, z to the 1/2. And there's probably one thing that I would ask you to do after that, and that is get rid of the negative exponents. Well, that's not so bad. These negative exponents are going to go down in the denominator. So it's going to be something like this. Log, I'll have an x cubed and y to the second in the denominator. And in the numerator, I'll have z to the 1/2. Because it doesn't have a negative exponent. It doesn't go down to the denominator. It's not affected by those. Now, what's another way to write z to the 1/2? Fancier. Square root. So, if you wrote z to the 1/2 here, I'd be fine with that. But if you write square root, then you might get a smiley face, or even, depending on if a certain team wins the Big Ten championship this weekend, maybe you'll get a bonus point. We'll see.
Oh yeah, that's this weekend.
That is this weekend, yes.
My whole
All right.
family is going to that game. Guess who's not going to that game?
Why? Because you're studying?
No, because I have work.
Oh, I think studying would have been a better excuse, but I'm sorry that you're not going. All right. Let's take a look at a different one. Kind of similar to the last one, where he asked to write this with one logarithmic term. This time, you've got a difference between these two. So the log of, the difference of logs becomes the log of a quotient. It's not log of m divided by log of n. It's just log of m over n. So in our case, it's going to be log of this divided by this. So, I don't know, maybe kind of give our eyeballs a little things, something to follow. That term is there. And then this term comes in the denominator. So log of this divided by that. You cannot cancel the 3 and cancel the m like that. If you did, I'd be most unhappy. But what you can do is you can factor m squared minus 9. How does m squared minus 9 factor? This is good review. Ladies, what do you got? How does m squared minus 9 factor? Something times something else. Go ahead. There you go. m minus 3 and m plus 3. Maher, thanks for being able to volunteer just as the same. All right, that looks good. But now what can I do? Now that I got it factored like that, now I can actually do something that I wanted to do just a minute ago. Go ahead. Cancel out the m plus 3s. That whole term disappears. That leaves you with, ooh, let's see, I just made a typo here. That leaves you with an m minus 3. The last thing to do is to bring this term here up to the exponent. So that's going to be m minus 3 raised to the 1/3 power. So like that. Or better yet, and again, this is probably a bonus point, log of the cube root of m minus 3. That's probably the way you see the answer written in a book or in WebAssign. I'd be happy if you got to here. Some of you have a fancy graphing calculator that can do this directly, and that's fine. If you don't have a fancy graphing calculator that can do this directly, then the way to calculate logs for these kind of obscure things that you can't do in your head, and even I can't do this one in my head, that'd be log of this divided by log of the base. Yay. And that should give you the right answer. Let's check it out 2 different ways. So the first way is the way I just typed it in. So log of 7, you got to hit the closing parenthesis, divided by log of 5. Okay, so we're good there. Let's try it a different way, see if we can't do it directly. And there's a few ways to get to this. The one that I remember, I think it's under the math menu. You can probably get it there. Is it under number? No, I'm not seeing it under number. All right, scratch that. Let's go underneath the format menu. So second and then format. No, sorry. Press the wrong button again. My bad. I'm just like blowing this here. Last try. Alpha and then the format menu. Help if I got out of this. Alpha and then format. No. How about alpha and then here? There you go. Log base. All right, so it took me a little while to get there. I apologize. Log base 5 of 7. And because I stumbled getting there a little bit, let me try that again. You hit the alpha key, then the window key, the 5th option down. That's your log. So for instance, Maher was quizzing me on my powers of 6 earlier. Log base 6 of 7,776 should be 5. Bam. Nailed it. All right. I thought it was in the math menu. Is it the very bottom? Oh, there it is. Yeah, log base. So there you go. I remember that there was another place for that. So let's do another one like log base 5 of 3,125. Should also be 5. Yay. Okay. Nice, nice, nice. Let's keep going. Some of the things that you'd be asked to do would be solve exponential equations. So here's a good example of an exponential equation. The way you solve exponential equations, that is something that has a variable in the exponent, not just like a squared or a 3rd power, but if you have a variable in the exponent, then you take log on both sides. So I took log base e. Notice that these two match. And I kind of recommend that when it's feasible. That's because when these match, I get a lot of nice simplification here. So log base e of 14.2, it's probably not the way I would write it typically. Typically, I'll probably write that with some other notation. Does anyone know what that is? Instead of log base e, what else could I write? ln. ln of 14.2. On the left-hand side, you get a lot of nice simplification. What's that nice simplification? What's left when I take the log base e of e to the negative 0.3? Excellent, excellent. That's this property again. These things cancel each other out when the bases match each other, and you're just left with the exponent. So that'd be negative 0.3x. And then to finish solving, you divide both sides by negative 0.3. On the left-hand side, all that stuff cancels. On the right-hand side, you end up with that. So, wonderful. That's a good one. Now, that's also an easier one. You're not necessarily going to just get easy ones. So before I move on from the easy one to the hard one, are we okay with the easy one? All right. Let's take a look at a different one. And I've already got this one completely done out, so good luck trying to keep up with it, but I'll be posting these notes online afterwards. You could, if you wanted to, take log of base 6 or log of base 7 on both sides. It would work out eventually. But I'm not going to get both of them to cancel out very nicely. So I just took log base 10 on both sides here. If I just had one of them, then yeah, maybe I'd consider log base 6 or log base 7. But these don't match. You can't take log base 6 on one side and log base 7 on another side. It doesn't work that way. You have to use the same base of the logarithm on both sides. But what I am going to do on both sides is use my exponent rule, my power rule, to get those exponents out in front, someplace where I can manage to work with them. So they both come down. I use parentheses for this because that log of 7 term has to distribute itself to both of these terms here. So that gives me this equation, x log 6 equals, well, if you distribute that, that's x log of 7 minus log of 7. Now I'm going to get a little bit fancy here. I need to get x by itself. And so the way I'm going to do that is I'm going to move this log of 7 term to the left-hand side because there's nothing in terms of x associated with this term. When a term changes sides, what else changes? The sign. Thank you. So that's going to become positive over here, and this is going to become negative over here. This is what it looks like. I'm getting closer. I want to get the x by itself. And if you notice, x is the greatest common factor. So I'm going to factor that x out behind everything else here. If you distribute it, x times this gives me that. X times this gives me that. So these two are equivalent. But now that allows me to solve for x. And in solving for x, you can divide both sides by this ugly mess. And that's what you're left with. Yay. So that one's harder. No doubt about it, but at least you've got a heads up as to what something might look like there. Comments or questions before I move on from this one? I'm happy to spend another minute or two on this one if you'd like. All right. Let's keep rolling. You will have one problem like this, where you have to solve a 3x3 system of equations by hand. And I want to see the work here. From my point of view, I would suggest that you pick one of the equations to use to eliminate a variable from the other equations. I look for something that has a coefficient of 1 or negative 1. So this equation here, the third equation, has a coefficient of 1 for both the y and z coordinates. Now you're going to pick one variable that you want to eliminate from the other two. I chose to eliminate the z's from the other two. You can choose to use this equation to eliminate the y's. If I wanted to eliminate the y up here, I'd multiply this by what? To eliminate the y up here? -6. But I'm trying to eliminate the z, so I'll multiply this by negative 3. Negative 3 times that gives me this row up here, and I've kind of tried to highlight the change in the coefficients here. When I add that together, I get negative 4x plus 3y equals 1. And then you leave that equation for just a minute. You need to do that operation again. I need to get rid of the z from the second equation. So that would be 3 times row 3 added to row 2. It's helpful for me if you show this notation on your paper. I can follow it easier. If you make a mistake, I can give you more partial credit. When I multiply 3 times row 3 and add it to row 2, I end up with 18x plus 5y equals 51. Now there's a lot of different ways that you can solve this system of equations, but I'm going to be really cute about it. It's not something you can do as easily on the exam, but one way you can solve a system of equations like this is by graphing, right? What does it mean to solve a system of equations by graphing? Or what am I going to be looking for? Does anyone know? This is my little 2x2 system of equations. Well, let me go over to Desmos. Here's the first equation. Here's the second equation. Can anyone tell me the solution? There you go. 2, 3. That's the solution. Nice. The solution is where the graphs cross each other. Now, if your graphs don't cross each other, then it's an inconsistent system of equations. If I had negative 4x plus 3y equals 5, those are two parallel lines. They never cross each other. So the fancy term here is that it would be an inconsistent system of equations. Inconsistent, independent. Why independent? It's independent because the lines aren't the same. So if the lines were the same, like if I had, say, negative 6x, or excuse me, no, negative 8x plus 6y equals 2, then those two lines would be essentially the same, one right on top of each other. Does anyone remember what this kind of system of equations is called? Dependent. Good. Where the system really represents two of the same line. So the solution here is 2 for x and 3 for y. You can get that by substitution or addition, whatever works for you. But if you substitute in this for x and this for y, you can finish solving and get z. So, nice. All right, let's keep going. One of the things that you might be faced with is actually just coming up with a system of equations. We saw stuff like this with one of the food examples that we dealt with, where you have 3 different sources of food, A, B, and C. Your diet's trying to get so much niacin, that's a B vitamin, zinc, which helps oxidize alcohol, and vitamin C, which is an antioxidant. So some important nutrients here for you, but you have to come up with a system of equations. Well, there's 3 unknowns, how many servings of each of these you have, and that means you're going to need 3 equations. So your equation is going to look like, the first one's going to be 1 times A, or just A, plus 2 times B, or 2B, plus 2C. And what should that total up to? 22. And then the next one, A plus B plus 1 times C is C equals 12. The last one is 2A plus 1 times B, or just B, plus C equals 20. And if you're curious, if you wanted to go solve this one afterwards, and this is not a bad one to solve, you want to check here, the answer is 2, 4, and 6 is going to give you the right combination. I wasn't here for you from section 12.4. So I'm going to set the bar really low for us. You should know what an augmented matrix is. It's the way to start bridging a gap between computers and calculators and doing things by hand. So an augmented matrix is just this system of equations written without the variables, but just the coefficients. So the coefficients here are 1, 1, 1, and 4. And then 2, 1, -1, and 1. 2, -3. What should I write here? 0 and a 1. So that's your augmented matrix. You could be asked to go this way, or if I give you the augmented matrix, you should be able to write down the system of equations. That's it. Maher, you're shaking your head. Is that too hard? No, you sure? I could leave this one off. All right. I would expect one like that. 12.5 again. I wasn't really here. A 2 by 2 matrix. You should be able to calculate the determinant of that. It's just this times this. So 5 times 7 minus -3 times 6. So 35 minus and a minus, we have plus. 18 is 53. Done. I might give extra credit if you can show me that you can calculate a 3 by 3 determinant on a calculator. Center and radius of a circle. We did a lot with circles, so you should be comfortable with those. You might want to star this one. I kind of like these problems. It asks you to complete the square, essentially. So what you want to do is you want to get your x terms together. So I got an x term here and an x term here. Put them there. And then likewise with the y terms. Y term and a y term. And then notice I put a blank next to each of these. That's because I'm going to complete the square on both of them. You remember the process? What do I got to do to figure out what number I'm going to put here? Take half of the middle number, which is 2, and then square that and get the 4. So I'll put a 4 there. Now by putting a 4 on the left-hand side, I've also got to put a 4 on the right-hand side. So I add 4 to both sides. I'll do the same thing here for the y coordinate. Multiply that by 1/2, I get 1. 1 squared is still 1. Now on the left-hand side, this is a perfect square. And this is also a perfect square. What do I square to get this one? Any help on that one? X plus 2. Good. Make sure you put in the x as well. Thank you. Over here, y plus 1. There's a plus between these two things. So perfect. Now you can tell me the center and radius. Center, radius. What's the center? Awesome. -2 and -1. And the radius is 3. Beautiful. What's the vertex of this? In which direction does it open? Start by looking at the squared term. X and y. What value makes the squared term equal to 0? What value of y? Thank you. A 1. And if I put in a 1 there, 1 minus 1 is 0. 0 squared is still 0. 0 minus 4 is -4. There's your vertex. Done. Which way does it open? You've got 4 choices. Up, down, left, left and right. Which way is this one going to open? Anyone? Yeah, we can eliminate these because they have to be a parabola in y squared to open up and down. So let's get rid of those. And in fact, I can get rid of one more. It'd be this one, because this is a positive term. It's going to open to the right. So, nice. Section 13.2 is graph and ellipse. I'm not going to take the time to do that now because I'm already over time. But in 13.3, you should be able to graph a hyperbola. First things first, where is its center?
2, -1.
Good. 2 and -1. So that's down here. Now when you get this, you're going to put it in the right form by dividing each term by a squared number. Which one is this open? Left and right or up and down? Left and right. Because the x squared term is positive, it's going to open around the x-axis. You're going to find the vertices plus and minus 3 to the left of center, and then plus and minus 2, you find a couple more points. Those constitute your rectangle. I'm going to want to see your rectangle. So we'll draw all 4 points and then connect them with a rectangle. We're going to draw the diagonals of the rectangle. And that'll be the asymptotes for our graph. And those asymptotes help us graph the rest of it. Now, in doing some of the homework, some of you found it says plot 2 points when x equals 3. And you substitute it in, and it takes a lot of work to find the value of y. One hint, when you're solving after you substitute in, multiply both sides by the lowest common denominator so that you can clear out the fractions. But when I draw in my diagonals like this, now I'm all set to draw the graph. And it's going to come close to, but not quite touch, these asymptotes. Now I am going to cut you some slack. If it accidentally touches it, that's fine. There's actually a couple things that I ask. One is that you don't ricochet off of this. I mean, some people are so afraid of like touching this that they kind of bounce out like that. No, that's not so good. Some other people are so bent on making sure that their graph touches that they'll do this. They'll say, oh, okay. I'll just kind of trace that. That's not what I'm looking for either. But beyond that, I think it'll be pretty generous. That should do it. Comments or questions? See ya.